Hey guys, this is going to be the second video on Earth's motions. And these are the three things that I'm going to try to do today. That is, determine the relationship between weight and gravity and mass. Second one is explain how distance influences the motion of the moon and the Earth. And the third part is, why do I float on the moon and not on Earth? All right. So I'm going to be following along in the textbook, but a long time ago, there was a famous scientist and mathematician. His name was Sir Isaac Newton. And he kind of discovered gravity, or came up with the law of universal gravitation. And if you remember, gravity is the law that says every object in the universe attracts every other object. So gravity is what attracts objects together, or it pulls on something. Like, for example, you know that gravity pulls that marker downward. That's what that is. And the gravity, or this force of attraction, or the force of pulling things together, that is determined by their masses and their distance between them. And so I'm going to start getting into this part, determining the relationship between weight, gravity, and mass, and how they are all connected. So when you think of mass, mass is just the amount of matter that is in something. So for example, like you, me, the book, this paper, we're all made up of mass, or we all have mass, but we are all made up of matter. So the question is, how much matter do we have? So that's the question. Now I do want to clear one thing up. Mass does not always mean big or bigger. Like sometimes we might say something like, oh, that's massive. That doesn't always mean that something is bigger. And I'm going to show you. Like, for example, I have a quarter and a balloon. And right now, if I'm just holding them in both of my hands, you could probably imagine which one is heavier. It's the quarter. The quarter definitely feels heavier. And that makes sense because the quarter is made up of metal, and a balloon is just made up of like rubber and air, and that's it. So, what could I say? Which one is more massive, do you think? Well, it's actually this. The quarter is actually more massive because it has more matter in it. It's made up of metal, so it definitely has more matter. Again, the balloon is just air and a thin layer of rubber. So even though the quarter is smaller in size, it has more matter. It's more massive. The quarter is more massive. All right. So now back to the book. I also do want to say something else, is that when we look at this sentence, the greater the mass of an object, the greater the gravitational pull of that object. And this kind of gets into this term weight. But before I start that, let's go back to our quarter and balloon. Since we know that the quarter is more massive, and we know that it's heavier, gravity, that means that gravity is pulling on this quarter more. So if I drop them from the same location, which one fell to the ground first? It's the quarter, right? Because the quarter is more massive, the gravity is pulling on it even more. So again, back to this sentence. The the greater the mass of an object, the greater the gravitational pull of that object. And this kind of goes into this word, weight. Definition of weight is determined by the force of gravity on an object. So kind of think about your weight. You probably weigh something like, I don't know, a lot of you guys probably don't even weigh 100 pounds yet. Like, let's say, for example, you guys, maybe somebody in your class weighs 75 or 80 pounds. That 75 or 80 pounds means that is the exact force of gravity that is pulling on you, that is pulling you towards the center of the earth. There is 75 pounds of force that is pushing down on you, forcing you down to the ground. And if you take somebody like Shaquille O'Neal or Michael Jordan or any of those guys, they probably weigh at least 200 pounds, upwards to 300 pounds. And they weigh heavier because the force of gravity is pulling on them more. Those guys probably feel heavier, and it kind of takes them a long time to move around because they have more mass to carry, and it kind of may slow them down sometimes. But weight is just, again, the force of gravity that is pulling on you. And the heavier you are, the greater that force of gravity is pulling on you. If you're somebody light, like 75 pounds, the force of gravity isn't pulling on you that much. All right. And then that kind of goes into this last part. Gravity is just the force that causes objects to attract each other. Like gravity is pulling that downwards to the center of the earth. That's gravity. All right. And go over this last question. Why do I float on the moon and not on Earth? All right, and this kind of goes along with weight and mass. So if you remember this sentence, the greater the mass of an object, the greater gravitational pull of that object. So if you were to look at the moon, do you think the moon has more mass than the Earth? I'll tell you now, it does not. The moon does not have as much mass as the Earth. So, because of that, because it has less mass, that means that the gravity or the gravitational pull on the moon is less, or it's smaller. So if you've ever seen videos of like astronauts who kind of float out into space or maybe jump on the moon, they could probably jump 20 feet in the air, or they could jump across 50 feet without even really trying. That's because gravity is not pulling on them very hard on the moon. Like I said, moon is smaller, it has less mass. So because of that, the gravity is not as much. It's not pulling on you. So if it's not pulling on you as hard, you can jump up as high as you want to on the moon. You can take 50-foot leaps if you wanted to. So that is why that you can float or jump really high on the moon. Okay, one more thing. This part. Gravitational pull also increases as the distance between two objects decreases. So I have this rubber band, and this kind of helps explain that. So the farther, the more distance there is between two objects, the less distance there is between the two objects, that means that the force of gravity is decreasing. So for example, gravitational pull also As the distance between objects increases, the gravity force between them decreases. So in other words, let's say you have moon right here, and you have Earth right here. And let's say that the from the very top of the rubber band to the very bottom of the rubber band, that is how much gravity is keeping Earth and moon together. Well, when the moon and the Earth, when there is more distance between those two objects, the smaller gravity becomes. You see how it's getting smaller? The smaller the gravitational pull. If they become closer together, if the distance decreases and they become closer together, the gravitational force increases. You see how it got bigger? So the distance increases, the gravitational pull decreases. If the two objects, if they become closer together, the gravity increases. Okay? So the big things is that gravity, the gravitational force between objects is between mass, and it's also based on difference. It's based on mass and difference. All right, I'm going to stop the video right here.